In this video, I'd like to review the most important things we've learned about lists and dictionaries in Python. For that, I'll be using the bpython command line interpreter, which means that everything I'll be typing is Python, which immediately will get executed and show the results, like this. Alright, so let's create a list, and I'll assign the list to the variable x. So the easiest way to create a list is just using angular brackets. Because there's nothing between these angular brackets, this just means create an empty list. When I evaluate x, you can see that it actually returns the same thing, an empty list. I can verify that it's empty by asking the length of the list, which will be 0 in this case. Okay, as an empty list is not that interesting, let's create another list. I'll create a list with some numbers in it. There. So this would be a list of length 4, 1, 2, 3, 4, as verified with the len function. A common thing to do with lists is to want to know the first element in the list, or the second, or the third, any number basically. And we can do that using angular brackets as well by suffixing them to the variable name. So when I want to know what the first number in the list is, I can do that like this. I'm stating 0 here instead of 1 because Python, like most programming languages, is 0 based. So the first element will be 0, this will be the first element, the second and the third. It's a little bit confusing, but there are good reasons for this. So this should return 10, and it does. And well, when I want to look at the next element, it's number 1, number 2, number 3. What would happen if I'd ask Python for element 4 in the list, which would actually be the 5th element because of the 0 basing? It would give us an error. List index out of range, meaning there is no such element within the list. This is only a list of that ranges up to number 3. A common scenario is that you do want to append items to the end of the list. Appending items can be done using the append function that is defined on every list. So like this. We're appending number 50 at the end. And when we look at the list, you can see that that actually happened. Now, lists aren't restricted to only contain the same type or only numbers. So we can, for instance, append a string to the end. Like test, or we can append a boolean. It doesn't matter. Now, when we look at x, you can see that there are different types within the list. That's not a problem for Python. Now, you might also want to replace a specific item. So let's say the second item, the number 20, should actually be 200. And we can do that using the same way as we used to read the value for number 20, like this. Only now we just assign to that. We put 200 at the first position, which is the second in the list. And there you see it has now been replaced. Okay, so these are the most important operations to create a list, to add to the list, to replace elements in the list, and to retrieve a single item within the list. There is one more thing that is very common to do with a list, which is to iterate it, which means to loop over the list one by one. So first we want to see number 10, and then 200, then 30, then 40, and so forth. Well, one way to do that, of course, would be to make use of the x0, x1, x2, x3 mechanism, right? And instead of using 0, 1, 2, 3 by ourselves, we could use a index variable. So we could say index is 0, and then create a loop while the index is smaller than, well, the length of the list. And then for each time we go through the loop, we can print the indexed element within the list. So that is the first time we go over this, element 0 out of the list would be taken and printed. The second time element 1, third time element 2, etc. And in order for that to happen, we need to increment the value of index by 1. And this is exactly the same as this. But this is shorter, so we like this. Okay, so let's see what happens. and it actually does print all of the items within the list. But as this is such a common operation, Python has a shorter and a better way to do this, which is using a for loop. So for value in x. What will happen now is that we'll loop over the list, and every time value will contain the next value. So the first time it should be 10, then 200, and then 30. So we won't be getting the indexes. It won't be 0, 1, 2. No, we're actually getting the values that are contained within the list when we do it this way. So when I say print value here, we'll get exactly the same as we did above. Yeah, like that. Sometimes, however, you're also interested in the index. For instance, let's say if we want to print before the value, we want to print which position in the array it has. You need to know the position. And we could have done that using this way, because within this print I could have used index as well as x square brackets index. But we like this syntax better. So the Python people came up with something for that as well, which is enumerate. The enumerate function can be applied on any list, and what it does, it converts every item within the list to a pair of items, where the first half will be the first half of the pair will be the index, and the second half will be the value. So what we basically get here is index value. So that it's a pair where the first item in the pair is the index and the second item in the pair is the value. So let's see what happens when I print that index value. You can see that indeed the enumerate function converts each of the items within the list to pairs, where the first half is the index, so that ranges 0 to 6, and the second half are the actual values. This index value thing is actually a tuple, which is very much like a list, only a list you cannot modify after it's created. But this is not really convenient. If we want to do our own formatting, we can. We could, for instance, say index value 0, which would refer to the first part in the index. Let's make it an F string. So index value 0, and then I want to see a colon and then a space, and then I want to see the actual value, which is index value 1. There, and we're closing the F string. So this would get us the list that I intended. But this doesn't really feel right. Index value is kind of a weird thing. But luckily Python has something interesting, is that we can it can automatically split up a tuple or a list into parts by putting a comma here. So what happens here is that the pair, which contains index and value, is split up in an index variable and a value variable. And this makes our print statement a lot easier, because the first part would just become index and the second part would just become value. There. And I think this is the most readable version that you can get in Python to do something like this. So that's enumerate. Enumerate adds the index for each of the items in an array. Okay, that's basically all about lists I wanted to repeat. Let's dive into dictionaries. The way to create a dictionary is using the curly brackets, like this. So this would be an empty dictionary. Let's see what Len has to say. Yes, it's empty. We could, of course, create a dictionary that has values in it right from the start. So what I'm going to do here now is create a new dictionary. And dictionary items, things you put in a dictionary, always are pairs of two things, a key and a value. So this would be well, my key, I'm just making a string up here, and some value. Another key and another value. There, you can see that it's actually within the dictionary. In this case, I'm using strings as keys and numbers as values, but it doesn't need to be that way. I can actually use any other data type as a key. So here I'm using a boolean as a key, and I can use everything as a value. So a string as a value, or I could use a number as a key, and then use I don't know, none as a value. It's all fine. Yeah. Similar to lists, you can access specific elements within a dictionary easily, as long as you know the key for the element you want. So, well, the keys here are my key, another key, true, and 789. If we want to, Python also has a function to show you which are the keys. It's y.keys. Well, and as you can see, these are indeed the keys. Well, it's not really a surprise. Well, suppose I want to know the value that the dictionary has for another key. Then this would be the way to do it, which is really similar to indexing a specific element within a list, right? Only now we're not restricted to just using numbers between the curly brackets. We can use anything that is a key within the dictionary. So that could be a number, or in this case it's a string. And indeed another key has 456 as a value. Another example, true, would have ABC as a value. Similar to lists, we can also use this to replace the value of belonging to a specific key. So if I want to replace ABC with DEF, this would be the way to do it. And when I show Y again, you can see that indeed true, the true key now has DEF as a value, and everything else in the array is the same. Now, what if I wanted to add another element to the array? In the list we would do append, which means add to the end, but a dictionary doesn't really have an end. Dictionaries don't have a consecutive index, they just have the keys. So what we can do for dictionaries is just make up another key as we go along. So this is new, and I can of course use spaces. So I can use any string, right? And just put in some other value. And now it just created this key for me and associated it with this value. Yeah, it added it at the end of the dictionary. What if you wanted to retrieve a value from a dictionary, but you're not really sure if it's in there? So let's say I want to retrieve a known key. And of course it's unknown because it says so here. But let's see what Python has to say. It gives us a key error, repeating unknown key, which means the dictionary doesn't contain any key that is named unknown key. That is the string unknown key. This gives us an exception, and we could handle the exception using try and except, which works, but it can be a bit of typing. An easier way is to use get. So instead of using the angular brackets, we can use get, and as an argument we provide the key we want to get the value for. And what it does is it returns none when the key isn't set. And if the key is set, it actually returns the value. The reason you're not seeing any output here is because Python actually hides non-return values. So when I look up a key that actually does exist, like 789, oh, that's also none. Yeah, so it won't. So it's not showing it. Another example then, the key true. And you can see that actually delivers the value. Alright, so these are the most important things you need to know about creating dictionaries and adding values to dictionaries. The other thing you may want to do with dictionaries, like with lists, is to iterate over them. So to go over each element one by one. The simplest way to do that is using for key in y, and each key would just be listed one by one. There. These are all the keys we have. And now if I would be interested in the value, let's say I wanted to do something like before. I want to print the key followed by a colon and a space, and then we want to have the value. So how do we get at the value here? Well, it's kind of easy. We can just look it up within the Y, the dictionary, and we look up whatever is in key. So the first time we go over this key will be my key, the second time it will be another key, the next time it will be the boolean true, then it will be the number 789, etc. And it will just look these up and get the value for it. So this actually works. It's not the shortest way to do it. In this case it's pretty much okay. Y is a short name, so this doesn't really get all that long, and we're just using Y key once here. But very often you will need to refer to the value a lot. And Python has something for that, which is called items. Items, like the enumerate function, converts every key value pair actually into a key value pair. So instead of just listing the keys, it will now retrieve pairs, tuples, containing the key and the value. So we could do this, which means that key value is now a tuple, and key value angular brackets 0 would be the key, and key value angular brackets 1 would be the value. But like before, we can do it like this. Python automatically splits up the tuple for us into two parts, a key part and a value part. And now we can do the same as before, only it reads even better. Key value. Okay, so that's items. And now if you want to go really crazy, sometimes you want to also have an index. So to say the first item within the dictionary has key this and value that. The second item in the dictionary has key this and value that. We can combine y.items with enumerate like this. So first, for each item in the dictionary, for each key value pair, y.items will make sure we get a tuple that has the key and the value, and then comes enumerate, and it will create another pair where the first item is the index, so 0, 1, 2, 3, etc. And the second item is the key value pair. Well, first let's see how that looks. Oh, sorry, let's go back. Go away. Let's just put it in a variable, and I don't know what to call it yet. I'll call it temp, because we're just trying to discover what it actually is. And when I do this, you can see that indeed we have a tuple within a tuple. So the outer tuple, it contains the index as the first element, and it contains the key value pair as the second element. And the second element contains the key as its first element and the value as its second element, like items does. So what we can do now is destructure all of this at once. So we'd get an index and a key value. Only this key value can be further split into a key and a value. And in order to do that, we need to add some parentheses here. We can say key value. And then we can create a print statement something like this. So we add an index with a dot and then a key and a value. There. So here's the index, there's the key, and by the end of the line is the value. This should be enough to get you started with lists and dictionaries. Enjoy!